In this video, we will be exploring limits graphically. Let's start off by analyzing this crazy function f of x that's shown here. So for problem number 1, we need to find the value of the function at -5. So here's -5, and at -5, the function has a value of 2, because we're looking at this spot right here. So f at -5 is 2. What about the value of the function at -2? Well, if we go over to -2, and then if we sort of look up and down, we should be noticing that there's a closed circle right here. This is the value of the function at -2. And the answer is 3. So we will, of course, ignore the open circles, because an open circle means that the function does not exist at those particular points. All right, let's move on to problem number 3. What is the value of the function at -1? So if we go over to -1 and then look up and down, we have to look down here for the closed circle. All right, we've got the closed circle at -3. So that is the value of the function at -1. And what about the value of the function at 4? So if I go over here to 4, there's an asymptote here. That asymptote is there showing what is happening to this portion of the graph that's approaching from the left. But I see that there is a closed circle that is right on that asymptote, and that is okay. That's allowed. And that is at a value of 3. So the value of the function at 4 is 3. Okay, so for problem number 5, we need the limit as x approaches 1. Okay, so here is an x value of 1 right here. So the limit is going to be what the function is approaching, the y value that we are approaching as we get closer and closer to an x value of 1. So as we get closer and closer to 1, the y value is getting closer and closer to -2. So that's the limit. All right, what about the limit? So this notation right here with a little 2 and a little negative sign, remember that means as x approaches 2 from the left. Okay, the little minus sign means from the left. So if we are approaching 2 from the left, then the function is approaching 2 from the left like this. So we are getting closer and closer to this open circle, which is at -4. So that is the limit. So the limit will be the -4. It is completely okay that the function does not actually exist at 2. We have an open circle there. What matters is that we are approaching -4. Okay, number 7. The limit as x approaches -4. The fact that it does not say from the left or from the right means that the limit should be the same from both directions. So let's go ahead and look at what's going on at -4. So here is the x value of -4 right here. So we can see that as we approach -4 from the left, or whether we approach -4 from the right, it does not matter. We are approaching this point right here where the value is 2. We're at a y value of 2. Okay, the limit as x approaches 2. All right, well, so here's the thing. We talked about what's happening as x approaches 2 from the left a minute ago. So as we approach 2 from the left, the function is approaching -4. However, as we approach 2 from the right, the function is doing this. All right, as we approach 2 from the right, the value of the function is approaching 3. So because from the left we're approaching one value, and from the right we're approaching a different value, in that case the limit does not exist. It has to approach the same value from the left and from the right. So this limit does not exist. So we will just put DNE. Okay, how about the limit as x approaches -2 from the right? Again, that little plus sign means from the right. Okay, so we are approaching -2 from the right. Let me just clean this picture up a little bit. So if we are approaching -2 from the right, then what the function is actually doing is it's going like this. So we can see the function is getting closer and closer to the open circle, which is at -2. All right, so the limit is -2. How about the limit as x approaches -1? All right, so let me clean this up a little bit. So as x approaches -1 from the left, then the function is doing this. And as we approach -1 from the right, then the function is doing this. In both cases, we're approaching this open circle, which is at 2. So the limit is 2. And again, it does not matter that this is an open circle. All that matters is that the value of the function is approaching the value of 2. Okay, the limit as x approaches 4 from the left. Okay, so we are approaching 4 from the left. The function is going to be doing this. As you can see, as we approach 4 from the left, the actual function is falling as it approaches this asymptote. But it's going to just keep on falling forever. So because this is unlimited, it's not approaching a particular value, then the limit does not exist. So we will say DNE. This limit does not exist. How about when we are approaching 4 from the right? So now we're talking about approaching 4 from the right-hand side. And as we approach 4 from the right, the function is doing this. So the function is approaching this closed circle, which is here at 3. So the limit is 3. Okay, how about the limit as x approaches 4? Well, we just talked about the limit as x approaches 4 from the left and the limit as x approaches 4 from the right. For problem number 13 to exist, both of these would have to exist and be the same number. So because the limit as x approaches 4 from the left did not exist, then that means automatically that the overall limit as x approaches 4 does not exist either. Let's take a look at the limit as x approaches -2. So let's see, here is -2. As we approach -2 from the left, the function is approaching 2. As we approach -2 from the right, the function is approaching -2. So we have two different limits from the left and from the right. So that means the overall limit as x approaches -2 does not exist. Okay, the limit as x approaches -infinity. Well, as x approaches -infinity, the function is doing this. Notice that the function is flat at a value of 2. So it's just going to continue to be 2. So as x approaches negative infinity, the limit is positive 2. How about the limit as x approaches positive infinity? Well, something strange is happening. Let me just clean this up a little bit. As x approaches positive infinity, right, as we go towards the right, we have a periodic function happening here. So the y values are going down and up and down and up. And the idea is that this will continue forever, just down and up and down and up and down and up. So this is another way for the limit to not exist, because it will never approach a certain value. The y values will just keep on bouncing back and forth between 1 and 3 forever. Okay, so when you have a periodic cycle like that, we will say that the limit does not exist. The second half of this assignment is almost like a little game that we're going to play. We're given a bunch of instructions, and we need to sketch a graph of a function that satisfies all of the criteria. So let's see. We need to draw the graph so that the limit as x approaches negative 3 is equal to 2. All right, let me start with that. So and we're going to draw it on this graph down here. Hold on, it's glitching a little bit. All right, so I'm going to draw it right here. So as x approaches negative 3, okay, so as we get closer and closer to negative 3, the limit is supposed to be 2. All right, so I'm going to go ahead and put an open circle at 2. All right, because this is going to represent my limit. So for this to happen, I have to be approaching 2 from the left, and I also have to be approaching 2 from the right. So I'm going to have something like this going on. But there's a little bit more information here. It says that the value of g at negative 3 is equal to 1. Okay, so right at negative 3, the function has a value of 1. So I'm going to put a closed circle right here to reflect that. So as we go, we are supposed to be describing what we are drawing. So what's happening at and around x equals negative 3? Well, we have an open circle at negative 3 comma 2. Okay, so so we have an open circle at negative 3 comma 2, and we have a closed circle at negative 3 comma 1. All right, let's move on to the next part. I think I'll change colors so we can sort of at a glance match up what I did with the instructions. So for this next part, we want the limit as x approaches negative 1 to exist, but the value of the function at negative 1 should be undefined. Okay, so we're given a lot of latitude here, so we just need the limit as x approaches negative 1 to exist. So that means as we are approaching negative 1, and I'm just going to put an open circle here. So if the limit is going to exist, then it's got to approach this value from the left, and it's going to approach this value from the right. But they're telling us that right at -1, the function has to be undefined. So by making it an open circle, it's undefined, and it will stay undefined as long as I don't put a closed circle somewhere else. So because of the way they asked the question, I could have put this open circle anywhere at -1. So I'm just going to say for my description that we have an open circle. We have an open circle at -1 comma something. Okay, moving on. So next we want the limit as x approaches 0 from the left and the limit as x approaches 0 from the right to both exist. But the limit as x approaches 0 overall does not exist. So the limit from the left exists and the limit from the right exists, but the overall limit does not exist. That means we have to be approaching two different values on either side of 0. Okay, so if I can scroll down, so here I'm approaching 0 from the left. Okay, that's fine the way it is. Maybe I'll just put a closed circle right here, just for fun. But then I'm going to put an open circle somewhere else as I continue my function. So the limit from the left is one thing, the limit from the right is something else. So because we are approaching two different values from the left and the right, then overall the limit as we approach 0 does not exist. So I have satisfied this. So what's happening around x equals 0? Well, we have a jump discontinuity. We have a jump discontinuity at x equals 0. All right. Next we want the limit as x approaches 2 to exist. And the value of the function at 2 is defined. And those two things are the same. So the limit that we're approaching is equal to the value of the actual function. So let's picture this. If the limit as x approaches 2 exists, that means that the function has to be approaching the same value from the left and the right side of the number 2. Okay, so here we are approaching 2. So I just need to make sure that we are approaching the same value from the left and we are approaching the same value from the right. All right, so we are approaching the same value. However, sometimes I will put an open circle in here if it's supposed to be undefined or something like that. And sometimes I'll put a dot somewhere else. But because of the way they described the rest of the problem, g at 2 is defined. So that means the value, maybe it'll be a closed circle or something like this because it has to be defined. It can't just be an open circle. But then at the end, they said that the limit equals the value of the function at 2. So the limit is this value that we are approaching from the left and the right. But then they're saying, look, the actual value of the function at x equals 2 is the same as the limit that we approach from the left and from the right. So because of that, there will be no open circle here. In fact, the best thing for me to do is just to draw a smooth curve connected here. Okay, in fact, maybe I'll just better redraw. Because what's really happening is kind of nothing is happening here. All right, there's no hole, there's no discontinuity at all. So in fact, we will just say that the function is continuous. At x equals 2. All right, now we're getting down to the last part. The limit as x approaches 3 from the left does not exist. Okay, so let me just deal with that. So here we are approaching 3 from the left, but somehow this limit, this one-sided limit, is not going to exist. So an easy way for the limit to not exist is if there's an asymptote and we're approaching the asymptote. So I'm going to go ahead and put an asymptote in here. Okay, so here's my asymptote at x equals 3. So this limit here from the left will not exist if the graph is, wow, it's not letting me erase, man. If the graph is approaching this asymptote. Okay, that's just going to be unbounded as it approaches the value of the function approaches negative infinity. So that will not exist. As x approaches 3 from the right, the limit is supposed to exist. So I'm going to draw that part of the function just approaching an actual value. So I'm going to go ahead and put a closed circle here. It could have been an open circle, doesn't matter. But from the right, I just need the function to be approaching an actual value. All right, so from the left, as we approach 3 from the left, the limit is undefined. As we approach 3 from the right, the limit exists because we're approaching an actual value. Okay, so that's it, really. This graph is now complete. If you did this on your own, your graph could look very different, but it just has to satisfy all of these criteria. So let's put one last description of what's happening at and around x equals 3. So there's my little description. The function approaches an asymptote from the left, but it approaches a specific value from the right.